First thing today, we will be talking about a new way of figuring areas when we aren't quite given all of the information we're used to needing for our triangle area formula. Then we will be looking at the systems of inequalities in the coordinate plane and how we graph those. So first kind of triangular area one we're going to do isn't actually a triangle, but it's going to be a trapezoid. I'm going to find the area of the trapezoid. Okay, do we know a formula for trapezoids? Ava, what is it? Okay, and I'm going to put a half in there instead of the over 2. Instead of dividing by 2, I'm going to choose to multiply by a half. I think it makes it just a little bit easier on some of the problems. So 1/2 base 1 plus base 2 times the height. Average base times height. Okay, I don't know the area. That's what I'm trying to find. Do I know some of the other things? B1, B2, H? Do they give me any of those? Abby? Do they give me B1, B2, and or H? Which do they give me? And they are what? So I can go ahead and plug in 1/2 and the 8 plus 13, but now I need to figure out what H is. Any ideas? Any things we can do to come up with what H is going to have to be? Morgan? How are you coming up with that? Okay, so we're going to have our sketch and we're going to draw in our height. We're not going to draw it right here, even though that's the height. That doesn't help us. That doesn't give us a right triangle. We can use our right triangle trig on. Similarly, it doesn't help us if we draw this triangle over here, because we don't know how long any of the sides are or how big any of the angles are. But if we do what Morgan was suggesting and draw a triangle right here, we do have a right triangle. And if that is H, we can use right triangle trig on that. For the 26 degrees that we know, H is what? Adjacent, opposite, hypotenuse? It's opposite, and 6 is hypotenuse, so opposite and hypotenuse does indeed mean sine. So we're going to do our scratch work over here on the side, that the sine of 26 degrees is H over 6. So H is 6 sine 26. Don't enter that yet. If you enter it now, then you've got to store it, then you've got to retrieve what you stored, and that's just more trouble than it's worth. We're going to enter this all at once. So some of you go ahead and enter it just like that. Others of you, why don't you enter it as, let's see, a half times the 8 and 13 is 21. I'm going to go ahead and do the half times 6 is 3. So some of you go ahead and enter it as 3 times 21 times the sine of 26 degrees. And others of you, since it's easy enough, just enter 63 sine 26 degrees. And I'm hoping we all get the same thing. Chloe, what do you have? Thumbs up, thumbs down. Others getting that? So that must be correct. How many of you entered it? Just raise your hand if you did the half 8 plus 13 times 6. So we have some who did that. How many of you entered it this way, 3 times 21? How many of you entered it 63? But everybody got the same answer, right? So if it's area of a trapezoid, that's what we have to do. We have to do that extra little step to get the height in there and then plug it in. We're not going to have a separate formula for a trapezoid area. So now let's do a triangle. And you're thinking, okay, good, we know triangles. What's the area of a triangle? Base times height divided by 2, or 1/2 base times height. Okay, do they tell us base or height in that picture? Maya? Do they tell us either base or height in the picture? Do they tell us at least one of them? Is there something in there we could use for the base? We could. That's going to be a little bit harder to draw. Usually when I'm thinking of a triangle, my base is, usually I try to turn it so it's the side on the bottom. Do I know how long the bottom side is? 16. Okay, so let's say that we want 16 to be the base. If we do that, that means the height has to go from 16 to the opposite angle, and it has to make a right angle with a 16. So that means that needs to be my height. But they don't tell me what that is. However, given the one that we just did, Kinsley, what can I do to find h? Okay, so sine of 42 degrees equals h over 12. So h is going to be 12 sine 42 degrees. And again, we're not going to enter that yet. So everybody good with what we've thought through so far? Now I do want you to enter that on your calculator. And you can enter it just like this, or you can go ahead and say 8 times 12 times that. You can do a little bit of it. Quick mental math if you would like. Natalie, what you come up with? Thumbs up, thumbs down, 64.237. Everybody coming up with that? And let's see, units will be inches squared. But let's take a look at what we just did and see if that gives us an idea for a formula. So we took our formula, a half base times height. And so we've got the half. Is a half actually labeled on the picture anywhere? No, but what about the 16 and the 12? What does 16 and 12 have to do with the original picture? Are they things we just calculated and came up with from somewhere? Billy? Well, then what? Okay, those were two sides that we were given, right? So these were two sides of the triangle. And what about the 42? Were we given the 42? Okay, 42 was given. Was it? It wasn't this angle up at the top. It was not this angle over here. How can we describe where that 42 is in terms of other things they gave us in the picture? How can we say that the 42 has to be there and not one of those other angles?
Would it have anything to do with like side angle side or something?
Kind of, but that's going to confuse us a little bit if we try to say it like that. Chloe, what were you thinking? So it's going to be the angle between the two given sides. In side angle side, we're trying to prove that we have congruent triangles, and we don't have congruent triangles up here, but the angle did have to be between the two sides. So we're just going to say the sine of the angle between those sides. So this has the makings of a formula in it. If we're given two sides and an angle between those two sides, at least for this example, it turned out that the area was 1/2, one of those sides times the other of those sides, times the sine of the angle in between those sides. So we ought to see if we can prove it with variables so that we know it's not true just for this kind of triangle. So let's do that. So first we're going to do it for a triangle very similar to what we just did. But then we're going to need to also think about a triangle like this. The difference being, if this is the base, one of the sides that I'm given, for this one the height is going to go down in the middle of the triangle. But on this one, if I'm given the base and an obtuse angle, my height is going to come down here outside the triangle. So I kind of need to think about, well, what happens if the angle I know is acute, and what happens if the angle I know is obtuse? So this one should be a little bit easier because it's the same idea of what we just did in that last one, but let's label a couple of things. B for base, just to be consistent. I ought to label another side that I know, so I'll call it A. And then I'll say that this is angle C, whatever that comes out to be. And then when I do this one, that will be my side A. That will be my angle C. It's going to be obtuse over there. So here C is acute. Here C is obtuse. All right, well, let's do what we did before. Area is 1/2 base times height. And so little b is the base. And we better figure out the height using our trig. We said that the sine of C was h over a, so h was a times the sine of C. So if I plug that in, I can then have the area is 1/2. I like alphabetical order, so I'll switch it to a times b. So multiply the two sides times the sine of the angle in between. So it's going to work when we've got an acute angle there. But what if it's an obtuse angle that we know? I can't do right triangle trig in this original triangle because it's not a right triangle. So the triangle that I'm going to have to use is going to be this one on the outside over here. So I don't know any angles inside that triangle. I know that obtuse angle C over there. Jack?
Would you have to do like 180 minus?
Exactly. This angle is 180 minus C. H is over here. So for this one, I'm going to say that the sine of 180 minus C is h over a. So h is a times the sine of 180 minus C. I don't know here. So if area is 1/2 base times height, that means I have 1/2 base times a times the sine of 180 minus C. I want the same formula. It would sure be nice to have. I've got no problem switching the A and the B around. Let's think about our unit circle and some things that we know from geometry. So if I have my unit circle and I have some sort of an obtuse angle here, so here is my obtuse angle C, so that this is 180 minus C. Would those y coordinates be the same? Because if this is 180 minus C, this would also be 180 minus C, right? So we're going to have the same thing there. So what's going to happen is, regardless of whether I thought about this as the acute angle or whether I thought about it as 180 minus C, I'm going to have the very same thing for my sines. This y coordinate for C is going to be the same as this y coordinate for 180 minus C. We're going to do a lot more of this next semester when we get into talking about which functions are something that we'll call even and odd, and some substitutions we can do as we do trig proofs. But for right now, have I convinced you enough that you're going to get the same sign value either way? So let's go ahead and write that down in our formula list. If we have a triangle and we know two sides and we know the angle in between those two sides, whether it is even or odd. So it's not like the vectors where I'm requiring you to use an acute angle. For this, you can plug in your obtuse values when you're using this formula, because we have shown that it's going to work whether it's acute or obtuse. All we have to do is know two sides and know the angle in between them, and we can use this formula. And we'll get that back up there in just a moment if you haven't quite finished copying it down. But let's give it a try and see how well this formula works. So we've got a triangle. Do we know two sides? Do we know the angle in between? So we can go directly to our new formula that the area is 1/2 one side times another side times the sine of the angle in between. So 1/2 times, doesn't matter if I do 14 times 10 or 10 times 14, times the sine of 130 degrees. And so you can enter it just like that if you want. I'm going to choose to say 1/2 of 14 is 7 times 10 is 70. If I were entering it, I'd just do 70 sine 130 degrees. Aiden, what do you have? 53.623. Anybody else? See a lot of heads nodding. And units here are meters squared. So nice little formula, don't you think? Any questions with that formula? Okay, let's move on to the second topic for the day. We now want to find the area of a segment of a circle. I thought segments were parts of lines. Does anybody happen to know what a segment of a circle is? Don't want to try to make a wild guess.
Maybe an arc.
Okay, but that would be like arc length that's not going to actually have any width, so we can't really get area. But that's kind of helping us get there. It's sort of arc, but not exactly. So let me give some picture definitions. A segment is going to be like what you see in the picture, this black part here. It's like you cut a piece of pie, and then you take kind of sort of just the crust, and that's your segment. Except it's not a curving kind of crust like on a real pie. So what you really do is you take a sector, a piece of pie, you take the biggest possible triangle that you can and leave that behind, and it's just that part on the outside. Formal definition in words up here, it is the area bounded by an arc. So if we take the arc from A to B, and then we take the chord, so the straight line from A to B, it's the piece in between there. Hardest part of these problems for students is reading the questions carefully. Sometimes they will ask you for sector, sometimes they will ask you for segment. So you've got to pay attention or you end up getting it wrong, because a sector is when we are talking about the whole piece of pie. Now I want you to also be careful when you're thinking about segments. They're not always real skinny. I could have a great big old obtuse angle here. When I take the chord that connects those points, look how fat this segment would actually be. So everybody kind of see what we're talking about with sectors and with segments. Okay, now we are supposed to find the area of this black shaded part. And I'll give you some numbers in a minute when I remove that shading. But first, let's just talk about our strategy. If you wanted to find the area of a section like that, what do you think you'd do to come up with that area? Okay. That's going to give me the area of the piece of pie of the sector. So how about our strategy is we want to get the sector minus the triangle? Everybody comfortable with that as our strategy? So we want to do the area of the segment will be the sector minus the triangle. And Kay correctly remembered that in general, for sectors, we do how many degrees we have out of 360 times pi r squared. Except this isn't degrees. This is radians. So how am I going to get the area of that piece of pie when I'm given it in radians? So our other formula, we already know that anytime we are getting a sector, it is a fraction of the circle times the area of the whole circle. Sometimes we know the angle in degrees, so our fraction is x out of 360 times pi r squared. And I don't care if you want to do it theta or x in your formula. If you are given your angle in radians, your fraction is no longer out of 360. How many radians in a whole circle? Come on, people. How many radians in a whole circle? 2 pi. So that's why we can do the theta out of 2 pi times pi r squared. Yes, I know we can then cancel the pi's, but I don't really want to try to memorize another formula of half the radian measure times just r squared. All I really want to remember is fraction times pi r squared. And I can do my fraction either way depending on how they give it to me. So far so good? Thumbs up? Okay, let's go back to our problem then and try to finish solving it. So we are going to have, this time we're going to have a half out of 2 pi times pi r squared minus, and I'll worry about the triangle in a minute. So my pi's will cancel. Do I know what r is? Radius is 8, so this becomes a half. 8 squared is 64 divided by 2. So let's see, half of 64 is 32 times a half. That piece is just going to be 16. So if all I needed was the sector, I'd be done. It'd be 16 square feet. Okay, now we need to come up with the area of the triangle. We know that r is 8. So on that triangle, do we know the height of it that's labeled with the h there? Not at the moment, no. Do we know 2 sides? Do we know the angle in between? Yes, we know it in radians, but we know the angle in between. So do we have a brand new formula when we know 2 sides and the angle in between? So we need to subtract 1/2 AB sine C for our new formula. And our 2 sides are 8 times 8, so we have 8 squared. And so let's see, half of 64 is 32. And then we have the sine of 0.5 radians. What are we going to do about that? Come on, somebody's got an idea. If it were degrees, what would you do now? Billy, what would you do if it were degrees? Yeah, we just go ahead and start punching in the calculator. But we've got a problem if we just put 0.5, if we do sine 0.5 on our calculators, don't we? Why do we have a problem, Avery? Okay, right now your calculator's set on degrees. So we actually have 2 choices. Yes, you could go in and change your settings to radians, and then just enter it, minus 32 sine 0.5. Or we could convert it. So let's take the sine, and we have 1/2, so 0.5, and that's in radians. What's our multiplier if we want to convert between radians and degrees? How many radians are equal to how many degrees? Pina? How many radians and how many degrees are the same as each other? So we could do 360 degrees over 2 pi, or when we wrote it down as a multiplier, we said we could just do half of the circle. 180 degrees is the same as pi. So what you are going to then enter on your calculator that is still in degree setting, 16 minus 32 times the sine of, I'm going to say 1/2 of 180 is 90. Just enter 90 over pi. That is in degrees, and tell me what you get. Elle, what do you have? 0.658. Anybody else? 0.658? I'm seeing some thumbs up. And what did we say our units were? Feet, and its area, so square feet. So questions on that? That's all of our stuff with triangular areas. I get how segments are related to that new triangle formula since we use that in here. You ready to switch to the totally unrelated topic of the day? Okay, let's graph a system of inequalities. So these are things with x and y. If these were equal signs, what shape is y equals 1/3 x plus 3? Louder. It's a line. What shape is y equals x squared plus 4x plus 2? So we have a line, and we have a parabola. When I have less than or greater than, what do I do when I draw my shape if I don't have an equal bar in there? I'm going to do a dotted or a dashed line for that. So for the line, I need to use dots. So y-intercept is 3, slope is 1/3, up 1 over 3. Back 1, down 3, so hopefully I got that pretty close to right. When you're graphing a linear inequality, what do you do about shading? Whenever you shade either one side or the other of the line, you have to figure out which side you're shading. Okay, which side do I need to shade for that line? Y is less than 1/3 x plus 3. How do I figure out where I need to shade? Natalie? How do you know? Okay, if I have y by itself, y is my second coordinate. It tells me how high or low I go. So it is saying my y coordinates are less than the line. So my y coordinates are below the line. So that lets me know that for this, I really need to be shading below the line. I'm going to wait to shade because I'm going to have other stuff coming up in that picture in a little bit. So far, so good? The other way you can figure it out is you can do test points. You're going to pick a point, and if it makes the inequality true, you shade that side. If it makes it false, you shade the other side. So let's suppose that I picked 0, 4. If I plugged 0 in for x, 4 in for y, I'd have 4 is less than 3. That's false. So I can't shade 0, 4 or anything else on that side. If I picked something on the other side, 0, 0, which is what I really would have picked, 0 less than 3, that's true. So I would shade 0, 0 and everything else on that side or everything below the line. Okay, parabola. Okay, this time it's going to be solid because I've got the or equal, but I got to get this thing in vertex form before I can graph it, right? So let's see if we can manage to do that. Let's see, y minus 2, I'm just going to do it with the equal sign for now. X squared plus 4x. So what needs to go in my parentheses? Sophie, what needs to go in that parentheses? I need to have an x plus 2, and x plus 2 times x plus 2, everybody, is x squared plus 4x plus 4. So if I'm adding a 4 here, I have y plus 2. So my equation is y equals x plus 2 squared minus 2. What's my vertex? So -2, -2. So right here. So this has to be my axis. Let's see, y-intercept. If x is 0, where do I want to go back to? If x is 0, y is 2. Did I get that right? And so by symmetry, I'd have this point, and I'd have these points. So my parabola is doing something like this. So now if I had just the parabola, y is greater than or equal to x squared plus 4x plus 4. How do I decide where I shade for just the parabola? I want you to think about the y coordinates are your up and down, because it's going to be above the parabola. If it's y is greater than, the y is above the parabola. So if I have a parabola like this, above the parabola is indeed inside. But if I have one like this that opens down, above the parabola is going to be outside. So that's why I want us to think about it as above and below. And if we aren't sure, we pick a test point and plug that in and see what happens. So I don't know, maybe we pick -2, 0, and we could plug that in. And let's see, 0, is that greater than or equal to? -2 squared is 4, plus 2 is 6, minus 8. Yep, 0 is greater than -2. So we'd be shading inside above this parabola. Now, your book a lot of times is going to say, let's describe where we would shade when we put things together in terms of, we can be above the line and above the parabola, or we can be above the line and below the parabola. We can be below the line and above the parabola, or we can be below the line and below the parabola. Would you agree those would describe the 4 possibilities? Your book's going to use letters, and there's no magic to A has to always be above and above or whatever. You can do them any letters you want. I can do M, A, T, and H if I want to for the letters. I don't even have to be A, B, C, and D. So I'm going to just say the order I happen to write these down, A, B, C, D, and I'm going to label that on the graph. Above the line and above the parabola, that's going to be this part in here. Above the line and below or outside the parabola, that's kind of tricky. That part is split into 2 sections. Below the line and above the parabola, so below the line, above the parabola, that's going to be this little piece in here. And below the line and below the parabola is all of this out here. So we have figured out that we need to shade below the line, and we said above the parabola. So which of my letters is that? So we need to then color in that we would be shading C. If we're drawing the graph, we'd shade it in like that. When the book gives you a graph, they're going to have the letters on there, and you say which letter is it. And you could plug in a test point out of that section if you wanted to and check that it makes it true. Anybody with questions on what we've talked about today?